Now we have to find the differentiation of secx with respect to x by using first principles of derivative. Now suppose fx is equal to secx, then fx plus h, it will be equal to sec x plus h. Then according to the first principles of derivative, the differentiation of fx with respect to x, it means the derivative of fx with respect to x, it will be equal to limit h tends to 0 right. Now in this we will substitute the values of fx plus h and fx, so we will get right, and it will be equal to what is sec x plus h, it will be 1 upon cos x plus h, and what is sec x, it will be 1 upon cos x, right, and it will be equal to limit h tends to 0 cos x minus cos x plus h upon cos x cos x plus h into h. So it will be equal to limit h tends to 0. So cos A minus cos B, it is what? Minus twice of sine A plus B by 2, that is x plus h by 2, into sine A minus B by 2, that is x minus x plus h by 2, that is sine minus h by 2. Okay, it will be equal to limit h tends to 0. Now see, sine minus x is minus sine x, so it will be twice sine h by 2, right, sine x plus h by 2 upon h, right. So what I'll do, this 2 I'll write here, okay, cos x plus h. So as h tends to 0, h by 2 also tends to 0, right, and we know that limit x tends to 0 sin x upon x is equal to 1, right. So here I will apply this theorem. So I will get this this limit will become 1 into limit h tends to 0 sin x plus h by 2 cos x into cos x plus h, right. So it will be equal to sin x upon cos x into cos x, that will be sec x into tan x. So the derivative of sec x with respect to x is sec x into tan x. Now we have to find the derivative of cosec x with respect to x. So let again fx is equal to cosec x. Fx plus h is equal to cosec x plus h. Then the differentiation of cosec with respect to x, or derivative of fx with respect to x, will be this limit. Now we will substitute the values of fx and fx plus h here. So I will get limit h tends to 0 cosec x plus h minus cosec x upon h. So what is cosec x? It is 1 upon sin x, right? So it will be equal to now we will subtract these two fractions, then the LCM of denominator will be sin x into sin x plus h. Okay, and now in numerator what we will have? Sin x minus sin x plus h. Okay, so it will be equal to limit h tends to 0 sin a minus sin b. So what is the formula of this? Its formula is twice of sin a minus b by 2 into cos a plus b by 2. So it will be twice of sin a minus b, that is x minus x plus h, divided by 2, that will be minus h by 2, into cos x a plus b by 2, that is x plus h by 2, that is x plus h by 2. Okay, sin x plus h into h. Okay, right? So it will be what is sin minus x? It is minus sin x. So sin minus h by 2 is minus sin h by 2. Now this 2 I will write here. Okay, cos x plus h by 2 and sin x sin x plus h, right? So it will be minus 1, because as h tends to 0, h by 2 also tends to 0. Now here h tends to 0, so this expression will become cos x upon sin x upon into sin x. So it will be minus cot x into cosec x. So the differentiation of cosec x with respect to x is minus cot x into cosec x.